And welcome to the CNY Central 2025-2026 Winter Weather Outlook. We've got our whole team of meteorologists here. I'm Peter Hall, joined by Josh Kozlowski, Violet Scibior, Mike Brookins, and Sam Postich. And we didn't just sit here all in a room just to look like, hey, we're all here in one room. We each individually on our own time looked up each research part of this. It was a research project. We did each of our own work and then also put it together to form a full forecast for you at home about how much snow we're going to get and the temperatures. Now, we like to use pie charts with this. So here it is. Here are the percentages for above, below, or near normal for snow and temperatures. So here we go for you. So looking at all the research, this is everything put together, okay? So notice we're going for a 40% chance of average snow for Syracuse. So that means around 127 inches of snow. We're going to show you the whole area as well in a minute. So there's a pretty good chance we're going to be close to what we had last year. We're also thinking it's about the same percentage for below average. Obviously, there's some left over here, so there's a 20% chance of above average. So if you look at this, it seems like, much like last year, there's a tendency that we should either be near or below average. That's the best chance. But according to our research, especially some research more than others, you're going to notice and find out later in this that there are and have been years with the same conditions we have this year and leading up to it that we could have a sizable snowy winter anyway. That's why there's a 20% chance. Now for temperatures, very similar. We've got this 40% chance again of above average temperatures like we've been seeing a lot of, not just during the winter, but also during other seasons, a 40% chance of near normal and a 20% chance of below average numbers. So that's the winter weather outlook. Now remember, we had talked about individual numbers as well. So I'm going to start and lead it off. We're going to show you each individual's forecast with respect to their research. So what I've done is looked at computer models. And yes, we look at those each and every day and night. And we use them to forecast hours ahead, days ahead, sometimes 7 to 10 or more days out, sometimes 2 weeks or a month. These are more for monthly, 1 to 3 month outlooks. So this is what I've researched and this is what I came up with. Now taking these full screen, first of all, what you're looking at is a conglomeration of 6 different seasonal forecasts per month. Okay, so you see all those things at the top there. Those letters and words don't mean much, but it's basically worldwide offices looking at each month and then averaging all of them together. You look at this, and first thing you notice for November is that it's much snowier in Canada and not much across the United States. And as we zoom into central New York, you can see we are below average. You can see how much we typically get in November. For December, note a couple of things. Northwestern tier of the United States and lots of northern Canada above average. But again, these models are predicting a below average December. We then look at January. Now this was interesting. Same kind of color coding, northwestern United States and Canada, but if we zoom into central New York and upstate New York, you see less red, especially near and east of Syracuse, especially for the Mohawk Valley and Adirondacks. They're saying close to average January snowfall, much like we saw last year, if you remember. And we look at February, once again biasing a lot of heavy snow Pacific Northwest and Montana and in southern Canada. But again, in upstate New York for February, typically December, January, February are our snowiest months, biasing for another below average month. And then here's March, again showing that same Pacific Northwest and much of Canada being above average for snowfall. And again, in upstate New York, most of the state showing below average with, again, a bias with northeastern New York showing less. So that's what the computer models have said. I also looked at QBO, which is an oscillation, which our other meteorologists, some of them have also looked at. It's also in this mode that tends to favor different types of winters, and that's why we're going to also discuss this with our other meteorologists. So my forecast with the computer models tends to say probably below average, but as you noticed, kind of bordering in the middle of winter, potentially being near average. That's at least what my research says. course, we've got everybody here, so I'm going to walk back to our friends, see if they have any questions here. So, Josh, Violet, Mike, Sam.
Pete, I got something for you.
All right, what do you got, Mike?
All right, you're mentioning 6 models. Do any of these take into account AI? I've been hearing a lot about AI with hurricane forecasts, and maybe in the future we're going to be looking towards AI models?
That's a great point. In fact, there are already some AI models for, like the European was one of the models that we showed over there. I've seen it for the next, let's see, 10 to 20 days or so, but I haven't seen, at least in my research, for that, but I'm sure it's something they're working on. But that's a great question. I think that might actually help in the future, yeah.
Stay tuned to next year for that.
That's a good point, and in the future as well, yeah.
These models you chose, I mean, obviously they go out such long range, which is what we want for a seasonal forecast, right? When you were looking at them, was there anything that you found that any one model has maybe a little better accuracy, precision versus other models, perhaps?
Yeah, that's the precision part. You look out with any model, even just a few days, everybody knows this, looking at a snowstorm or something, and there's always these differences. You go out further, and there's going to be a lot of differences. I can tell you, in terms of the 6 models that we showed, the European was one of the models. It was even more drastic for below average snow and much warmer.
Interesting.
So of those 6 or 7 models I showed, the European was very aggressive, being so warm and so snow-free, whereas some of the other models, including the United States NSEP model, was actually showing the potential for maybe a polar vortex-y kind of cold slipping in at some point during the winter. So it's interesting that they're going to all have their different biases and different thoughts. But in terms of precision, monthly and seasonal forecasts are always a tough one, that's for sure.
Yeah, I was going to say, with your overall monthly look at the snowfall, do you think that really includes lake effect or microscale type of snowfall events, or is it just our big nor'easters or widespread snow events?
I think Violet brings up a really good point here. Monthly and seasonal forecasts, I can't imagine would be able to pick up the mesoscale like lake effect snow. And considering that the last even few years where we had below average to near average from last year, there was heavier snow up north. And some of the models show a zonal flow. I don't want to get too deep in the weeds with this, but very fast-moving systems instead of coastals. Fast-moving clippers, I think, may actually mean heavier snow for the snow belts east of Lake Ontario, potentially getting a lot of snow, much like they did last year. Yeah. There you go. So good questions, and we'll see what happens with all of that.
I'm rooting for the European solution myself. I know skiers aren't going to like that.
I think it'd be all right if we can get some breaks where, okay, we get a big dumping of snow, maybe it warms up a little bit so you can enjoy the snow on the slopes, and then as opposed to maybe just having 2-3 months long.
Take care of the driveway, let it melt a little bit.
There you go.
Yeah, that's the one downside.
I mean, I'm only one part of this, okay? We have a lot more to talk about here. So we're going to go to our next piece of information. Violet, what did you focus on for this?
Right. So a big topic when we talk about winter forecasts is if it's going to be a La Nina or an El Nino. You've probably heard that. We talk about it every single year. But I'm going to get a little more in depth about what that means for central New York's weather. So let's head over to the computers and show you first what a La Nina and El Nino is. Because just a quick refresher is always good to just explain what that even is. This year, we're forecasting a weak La Nina. So a La Nina happens when we have really strong trade winds. Trade winds, you have to head down to the tropics. These winds blow from east to west across the Pacific Ocean, and that's where we get our sea surface temperatures. So there, when we take the temperature, we get colder water in the eastern Pacific with those strong trade winds. What's happening is the wind is pretty much shearing the water out to the west, taking all that warm surface water and just pushing it out to the west, which means we have colder water upwelling is what it's called in the eastern Pacific, and that actually impacts our jet streams or our fast-moving bands of wind that are our road maps for our weather systems, what they follow when they move from west to east across the U.S. So, typical wintertime patterns during a La Nina include wetter weather for the Pacific Northwest, cooler temperatures up in Canada and the northern states bordering Canada, and wetter weather for the Midwest and parts of the Northeast. Depends where these systems roll through. Driest and warmest for areas down by Texas and heading into Mexico. So I looked at our specific numbers for this week La Nina. And just to explain overall, this is based on the sea surface temperature. This is what's called an anomaly. I don't want to really get too much into the numbers, but basically, if it's a positive number, it means El Nino. If it's a negative number, it means La Nina. So this is what the forecast models are showing for this winter. It shows very weak La Nina with negative numbers, only around negative 0.5 to negative 1. If it's higher than negative 1, that's what's considered a strong La Nina. Now notice, this is only for the first half of the winter. As we head into the second half of winter, it goes back to nearly zero. So what that means is neutral conditions. I know this is a lot of information, so let's just explain what this means. We're forecasting a weak La Nina, early winter, neutral late winter. So in summary, let's look at what we've seen in terms of snow, precipitation, and temperatures for similar seasons to what we're forecasting for this year. So I went back and I looked at the top 10 most similar winters that had that weak La Nina transitioning to neutral. What did we see in terms of liquid and snow? So I looked at just the winter months. This is December through February. And I found there were a couple of outliers. 1950 to 51, nearly 12 inches of liquid just during those months. But a lot of months were near normal. Look at the left side of your screen. Normal liquid or precipitation is 8.3 inches. Most years were right around that for, again, this weak La Nina to neutral. But what does that translate in terms of snow? We know that we can get dry snow or wet snow, where it could be 1 inch of water making super, super fluffy snow up to 12 inches deep, or really compact wet snow. So liquid is not the entire story when it comes to snowfall. So the actual snow numbers for December through February, looking back at these seasons, we've seen a couple of outliers as well, over 100 inches for 2024 to 2025, 2017 to 2018. But again, most numbers were right near normal in the 90s for 2013, 2014, 2005, 2006, 1995 to 1996, and a couple of outliers that were on the low end. 1983, 1984, only 65 inches, 72 inches in 1950, and 78 inches in 2016. So let's average all of this out to just give you an idea of what we usually see for these similar winters, or at least the most common to what we're going to see this year. Overall, we're forecasting near normal liquid and near normal snow, which again, normal, we're expecting about 130 inches is our normal number for overall snowfall. For the winter months, 94.9 is our average snowfall. Liquid is 8.3 inches. So for this winter, it's looking pretty close to average. Overall, the temperatures were slightly above average for almost every single season. But there can be a lot of swings in the temperatures that add to that. So not really focusing too much on temperatures. It's really hard to forecast temperatures when you just take the average of each month.
True.
Because it doesn't encompass the entire picture. You could have a month that's above average where you just had a couple of events that were super, super warm, but it doesn't include maybe some cooler periods that weren't as cold as those super warm days, things like that. So
It's very interesting stuff. And you, as Violet comes back here, you may have noticed the jet stream she showed. Comparing it to even what some of the models that I showed, it showed wet and snowy in the Pacific Northwest. I don't know if you noticed that. So kind of almost shows the same kind of a forecast, very high probability of that area. I know it's not central New York, but also describing what you said, periods of up and down. That zonal flow will make a lot of fronts come through where you're getting warm-ups and chill downs. You could get very big fluctuations, and if you get a big polar plunge and then you get a big warm-up and then it averages out to, well, you had an average winter, people are gonna be like, well, that wasn't average. It's funny how that works, right?
Well, I was pretty amazed just by like the consistency of some of those numbers with your snowfall, you know. When you talk about a weak La Nina and just the amazing variety of weather you can get just through the course of a winter, and then your numbers were just all 90, 90, 90, 80, 80, 80, just right at about 100, you know? And so it's amazing just the consistently below average snowfall numbers with that weak La Nina. I was surprised by that.
Right, and hers were for the winter. It did not include March and November.
Yes.
Right?
Oh, okay.
Climatological
So,
Yes,
but,
you're
but-
right.
but- but it was
Yeah.
normal for those 3 months. So it was interesting that it kind of almost went with the normal to maybe a little below average that at least my number showed. Somewhat, right?
Yeah,
It
I
wasn't
mean,
a
I
lot
would
above
say,
average.
well, my research, I would say it was pretty close to average in terms of snowfall, almost
Sort of like
right on the
last
money.
year,
Okay.
right?
Yeah.
Sort of like last year. Last year we finally had a normal winter, which probably felt a lot wintry because we
Yeah.
haven't been used to it.
Yeah, and last winter we did have a neutral to weak La Nina pattern. So this is almost a reverse,
Oh, I
but
see.
pretty similar. This year we're forecasting weak La Nina to neutral. So we could see a similar snowfall total to what we had last year.
Okay, all right. So we've got Josh next. Now I think, Josh, you were telling me off camera that you actually have some overlap with what Violet and I were talking about. So let's get to that.
I did touch on both part of your topic
Okay.
and your topic
And
as
you
well.
also have
so-
completely your own thing too.
And I did.
All right,
I
let's hear
did
it.
my own research as well. Let's
Yeah.
get into it, right? So yeah, I was very curious for this winter because we just had a winter last winter with snow and a lot of cold, especially a condensed winter, I could call it. January, February was our winter last winter. I remember it being in the 60s back at the end of December. I was on the deck and I wish I didn't have to wear the button up in the shirt. I had the polo shirt on, but it wasn't, just to kind of give you an idea. December wasn't bad, but the condensed winter, when it hit hard. And a lot of last winter's snow, would you believe, was lake effect snow. And that really triggered my mind to say, okay, this year I got to look at some things that look similar to last year. So first off, I took a look, once again, like last winter, Outlook, at the North Atlantic Oscillation here. If we can take these graphics full screen, it'd be very helpful to show all the viewers and scrollers at home what we're looking at. This is the North Atlantic Oscillation. On the left, we call this the blocking. This is negative NAO. Think about very easily, negative, slower movement of storm systems across the United States and more specifically the Northern Atlantic Ocean. On the right side of your screen, you see positive NAO, which is a faster zipping of storm systems, which Violet and Peter both touched on with their part of the winter outlook. Now, I will tell you this. Why I also wanted to look at this year, again, is we have been in a positive, consistent positive NAO since February all the way through August. Almost every month this year has been positive, but September and October, we've flipped over to negative a little bit. So, knowing all of that, I went back and did some research and looked at similar years leading up to the fall and the winter. And the first thing I looked at basically was 11 years I found very similar to consistent months with positive NAO values. But would you believe it? Didn't help much at all. It yielded a 50-50 split with above and below average snowfall. Almost think of like a bell curve, right? Just like that. So interesting, but not really giving us much direction. In the same 11 years of those sequential positive NAO months, there was a change in the fall to September. I looked at that when it went from positive to negative in the month of September, and even in the month of October too. 36.5% of those seasons following were below average temperatures. 45.5% were average snow. So that kind of jives with Peter and Violet's forecast so far, meaning much of the percentage and probability could be below average snow to average snow. But you gotta look at temperatures too, right? And temperatures, as Violet touched on, very tricky to forecast too. And the monthly temperatures are always a little bit different because you have a week that was really cold and you got 3 weeks that was warm. You still remember the cold week and you know it was a bad week with temperature if you don't like cold, all right? 39 out of the 76 total winters that followed when there was negative NAO values in September and October led to, well, nearly 50% of the time an average snowfall season and 35% of an above average season. So very interesting when you have negative NAO values in the fall. All right, so that's one thing I want you to take away so far. And the next thing we're going to talk about, Siberian snow and ice coverage. I did this last year as well because I was very curious what's going on with the snow and the ice up by the North Pole, Siberia, Alaska. All right, if you look at this again full screen, we're going to look at basically on the left side of your screen, we have October, mid-October 2024 with the snow and the ice there, okay? You can see that. And on the right side, you can see 1 year later, Sunday, October 12th, 2025, snow and ice coverage. It's kind of hard to see from far away. let's zoom in, right? Double click on that, there we go. So 2024 October on the left, 2025 October on the right. A couple things to take away from here. The yellow, by the way, is the sea ice. Now this latitude right here, the circle in the middle, is the 75 degrees north latitude line. Notice how some of the yellow is crossing that line just north of, say, the Bering Strait and the east side of Siberia there in Russia, and also extending a little bit south closer to, say, closer to the line here, just north of northwest parts of Canada. On the right side, that part just northeast of Siberia and Russia there is a little bit more south. It's beyond the latitude line. More sea ice there, and also this part, this northwest part of Canada and northern Alaska, it's reaching a little further south there. As far as the white, you can see it is blotchy on both years, but the extent below the 60 degree latitude line, that top circle, is definitely more happening here in parts of southern Russia and also out into parts of, again, near Asia. You can see more of it kind of going further south, and also a little brighter there in northern Alaska, and maybe a little more consistent snow there in North Canada. So the point here is more snow, more ice has been building up, I think, a little bit this year than even last year, okay? So we get that more cold core happening in the North Pole. And also what that means is there's more potential drops in cold, like we saw last January, February. We saw the polar vortex, the dip down the cold down here in the northeast United States. So it could impact our weather. Not all the time, but more opportunities versus, say, weaker cold at the pole. All right, and it also impacts lake effect snow events. That was most of our winter. Most of our winter was lake effect. We had some general snow. All right, lastly, I did find an article, a couple articles actually, by the Severe Weather EU website. We'll show that website to you in a minute here. This is an example over many decades of what a strong polar vortex is. You hear in the news, you hear us talk about, polar vortex coming in this weekend, dropping the temperatures, giving us some lake effect. So over time, the cold builds and the low pressure, no cyclonic flow, counterclockwise flow, right? That's what's happening here. And if you use the right-hand rule, remember back in physics class, right-hand rule, right? That means lift. It means it's building the cold right here. So that's a strong polar vortex. What happens when the vortex up by the pole weakens or it gets disrupted or nudges of warmth come through and shift the winds around? Right here, pieces of cold dropping south, northern hemisphere. Here we are, there's Syracuse, there's central New York. Here's an example of when it can move down across much of North America, Canada, northern United States, the Northeast, but then you get these warmer periods and cold over towards Europe, et cetera. You see how kind of a fluctuation there, all right? Well, going back to touching on Violet's research with La Nina seasons, and here's that website, by the way, I mentioned, severe-weather.edu, where I got some of this information. Stratospheric warming means like the higher levels of the atmosphere right above where we are in the troposphere, where the winds are flowing the most, right? So when the winds are disrupted by a warming of the stratosphere, okay? And during La Nina seasons, La Nina's in the blue, okay? We're not gonna look at the El Nino because we're not gonna be in an El Nino this winter, a La Nina, as Violet touched on. November and December, you know, it looks like it's pretty low chances of the flow, the warming in the stratosphere to be disrupted. But when you get to January and February, and even a little bit of March, see how the levels here of the sudden stratospheric warming exceeds an El Nino year? That tells me there could be some of that disruption in the map you just saw there with the cold coming south out of the main polar vortex. And the last graphic I want to tell you about is geopotential heights, just the big word for looking at pressure systems high up in the atmosphere, very high up, almost as high as we can measure. And this is over a 30-year stretch, 1991 to 2020. The yellow, the oranges, are higher heights. In this case, we're looking at higher pressure in the upper levels of the atmosphere. But you want to see low pressure to maintain the polar vortex and keep it up north. But when high pressure can kind of build up over these many, many winters here, very interesting. Cold building, we have the La Nina, the QBO, I touched on that, negative QBO from Pete's research saying that can also be a reversal of the winds in the atmosphere, you know, in the trade winds down towards the equator area, and all this works together. And in these winters, when we have both of these interacting at the same time, it's led to this setup, which could give us some periods of cold and periods of snow, just like last winter. And I want to say this up front too, that there's still that 20% chance of an above average snowfall season, and this could be something that could get us closer to that versus just an average snowfall season. So
Yeah, and Josh, great stuff there. And that's why we actually we even increased the above average probability because of some of your research right there. Just to bring home everything you just said, what you're basically saying is since we have a La Nina and a negative QBO, that gives us a better chance that some of that Arctic polar air gets pushed down into central New York at times. That's basically what you're saying, correct?
yes, and I didn't want that to be, pardon the expression, kind of disregarding you and Violet's research.
But you're saying there's a better chance for that, right?
There are going to be opportunities. And to your point, saying in a month, like I said before, when you've got no snow, and you get a big snowstorm, okay, it doesn't tell the whole story of the season as a whole. It's just one example. And I think also when I talked about this last year with the North Atlantic Oscillation, the flow across the country, it's hard to forecast an NAO.
Of course.
Okay, so we don't know how the oscillation will be negative slow or positive fast for the whole winter. It could change, and I've seen in the past where it does change. It did change basically back when we got the snow in January and February last year.
It's like a tug of war recently. You've got
Yeah.
all these things pushing and
Yes.
pulling, and who's going to win out, and it's always that's why we're doing all this research. You
Sure.
can hear what we're talking about and all the different possibilities.
But yeah, I think there will be times this winter, and mind you, we haven't really had, in quotes, a bad winter
Yeah, right.
in a very, very
Yes.
long time. Your numbers actually, Violet, maybe you think of the winters before last.
Yeah, so
right?
that's actually something I was going to touch on is I think Central New Yorkers overall have forgotten what a normal winter is because last winter seemed so snowy, right?
Yeah.
It was right near normal.
Yeah.
And it seemed like it was so much snow. But the previous 5 winters before last year were so far below average in terms of snowfall that
We're
that's what we got
accustomed
used to.
to
Exactly. Yeah, we got used to that and we thought, oh, hey, this is normal. No, we just got spoiled by
a
easy
good point.
winters for a while. Yeah.
Interesting research so far. We've got more to come too. So we're going to go to Mike Brookins. Mike, what did you focus on for your winter weather?
I can tell you one thing. I didn't talk about the polar vortex one bit.
Hey, that's okay. What did you talk about?
You were talking about the teleconnections. You were just
Yeah.
talking about the El Nino out in the Atlantic Pacific Ocean. You're talking about the North Pole going into the North Oscillation as well. I'm focusing right here in central New York.
Okay.
Something we can do right in our backyard.
All right.
So
I
let's
love
go over
this.
to the Weather Center.
Yeah.
You guys are going to have to pay attention.
I'm listening.
I'm going to
Okay.
go over some ideas. We're going to give quiz you guys
Oh my
as
goodness.
well.
Oh, boy.
All right.
I didn't bring my pen with me.
So I didn't focus in on that rodent that does the forecast.
Oh, yeah.
What is that in February? What do they call him?
Punxsutawney Phil.
Punxsutawney Phil. Yeah, I didn't focus on him because
okay.
we're speaking of winter before the winter gets here, and I've got my broom here. Not
So you're gonna
because
be a
I'm a
sweep?
witch. I'm not forecasting like a witch would be.
Right, right.
We're going to have some examples, so
Okay.
just stay tuned for that. We're going to get into that. But something that a lot of people know when we talk about winter weather forecasting and folklore is this guy, the woolly bear caterpillar. First, we're going to focus more on animals, and then we're going to get more into the nature side of weather folklore for forecasting winter, and lastly, climate, what we've had now and what's coming in the future. But let's talk about these. Aren't they cute when they go along the street there? Well, they could tell you something because of the color pattern on them. Let's talk about it. When it's more black than brown, that is going to lead us to a harsher winter. That means cold and snow. I don't like that. What I like to see is this, more brown than black, and that's going to be a milder winter. So you want to take a look at them. You can pick them up, just be nice to nature, put them back down when you're done, and something with more black than brown looks like this. Now, I actually saw a picture from Mark McLean, one of the meteorologists over in Rochester at our Sinclair station, and he was hunting down the woolly bear caterpillars, and he saw that one with more rain, so a little bit more. Let's look at other things in wildlife. Specifically, we're going to look at the tail of a squirrel. Isn't he cute in his little nut there? By the way, people uploaded these pictures to our chime in at CNYCentral.com. So that's where I got some of these great photographs. Nice. So he's in there doing his patriotic thing, eating his nuts, which we see them doing a lot. And what does it mean if he's got a very bushy tail? It means winter is going to be harsh and snowy. So if you notice a lot of fur on them, that's what it means. Also, let's look at squirrels and look at their activity. If it's early on frantic, where they're going nuts for the nuts, that means severe weather, if they're gathering those nuts early. I know I've got those those sharp, piney nuts that fall from the trees. They make a mess on my driveway. Don't do it, squirrels.
Yeah.
Just don't do it. I've heard
somebody
if
else's.
if you live in a yard, a property, like you got to get rid of them somehow. So I've seen kids with lacrosse sticks. They pick up those nuts and they throw them into their neighbors' yards.
Well, that's not a good.
All right. Canadian snow geese with winter folklore. What do they tell us? We often hear them in the sky. We see them forming those V migration patterns. If it's early in the year, that's a cue that we're going to have a severe weather. All right, let's get to a little bit of a quiz now. So hope you're paying attention here. Winter could be quite tough, cold and snowy if spiders. You see the webs, we're nearing Halloween. A, they're hard to find around the fall equinox. B, are engorged from eating insects. C, burrow inside jack-o'-lanterns. Or D, spin larger than usual webs. Anyone got an idea?
B.
I'm going to go with B myself also.
We got 2 B's out there.
we got?
Engorged from eating insects. You'd actually be wrong. It's spinning larger webs so they can catch their prey, so they get a little fatter. Also,
See, I just tried to stay away from the
You
spiders.
didn't give me a chance. I was going to go D.
All right, we got more quizzes.
all the above?
You guys will get your chance. All right, now this is the fun part.
Okay.
Hold on a second.
All right, there's more to come. Oh, we got props.
So you see this?
Okay. You're cleaning that up, you know.
That's what the broom's for. See, I'm playing.
Oh, I see.
got the
Very
broom.
nice.
It's
All
okay.
right, guys, this would be called a leaf drop, right?
Yeah.
All right, if you had to say this year, did we have an early leaf drop or a late leaf drop? Any ideas?
Semi-early.
Early.
We got a whole bunch of earlies out there. Well, let's see what it says for an early leaf drop. Winter will be warmer and less snowy. Ooh. You'd think maybe winter was coming early, that's why. I don't know, I think it might have been because of the stress from the dry weather we
Yeah,
had
that's
over the
what I
summer.
thought, yeah.
So I don't know if there's a direct correlation
Okay.
there. What about corn crops? Then we got our next little thing here. So we got our corn.
I
ear
love
of
these
corn
props,
here.
Brookins.
We got this. This is from Reeves Farms
Excellent.
up in Baldwinsville. Love
Yes,
their corn.
delicious.
Very sweet. So we're going to open it up here.
Okay.
Hopefully there's no bugs. Once again, I'll be cleaning this up. And what we're going to do is we're going to look at the husk.
Okay. The
How
husk.
tight it is. How hard it's to get open.
Oh,
Okay.
And how thick it is. How tough it is.
What do you see in that
Yeah.
one?
Yeah.
Okay, we're going to do it live. I'd say this is pretty thin.
Okay.
Thin.
You think it's thin?
I
Okay.
think it's thin.
Okay.
I think it's a thinner corn husk. A colder winter if you have thicker, tighter ones.
Wow. So that's
Then-
another thing that's saying less
Warmer.
winter.
Yeah,
Yeah.
that would be warmer.
See,
And
shrimp?
lastly, I've got one here. I'm going to take a bite of this.
Yeah. chew that up.
Apple, Wayne
Delicious.
County.
Is that a
some of the
Macintosh,
best.
Mike? What do you got there?
Empire.
Oh.
New York State, man.
Okay.
It's a little small.
The last question here. Winter could be quite tough, cold and snowy if apples, A, drop from the tree limbs early, B, have a thicker than normal skin, C, taste extra sweet, crispy like that one, or D, the skins turn reddish brown.
All right, I'm going to take, I got to think
What do you
about
guys
that for a
think?
minute. Give me a
Oh,
second.
1 second.
Which one of these
I'm going to
could
say
make
A.
winter snow and cold?
Yeah, I'm going A too.
A, we got two
Yep.
A's.
I'm going to go B.
What about you, Josh?
I'm gonna go D.
Peter, you got it!
Oh my gosh! What do I
Now-
win? I get to clean up the leaves?
You got the rest of the apple. Now, this is also a sign, a traditional sign found in the skin of onions,
Okay.
but I was not about to,
Well,
do this,
right.
snap into a
Oh,
smoothie
I
God.
don't want to
with an
be
onion.
around you either, but yeah.
All right, so let's move on from that. Now let's talk about the weather. Foggy August mornings with
I
winter
love this
folklore. So you
folklore
look
stuff.
at what happened in the past to
Okay.
foretell what's going to happen in the future. Kind of like the groundhog coming out and seeing its shadow. But in August specifically, if it's foggy, winter will see the equal number of snowstorms.
So how foggy does August have to be to do that?
Well, you count the number of days.
Okay.
So if it's foggy 8 days, you're going to get 8 snowstorms.
Oh,
This
I
is winter
see.
folklore.
Oh, okay. No, that's okay, but I get it now.
So you guys got all your
snow
numbers and
events,
your
right?
maps.
Mike,
So you're
Mike?
saying if there's 3 foggy mornings, it's 3 snowstorms?
Yes.
Okay.
And are we talking about like nor'easters or lake effect?
I think snowstorms.
Okay,
So
larger
if
scale,
you're in
okay.
somewhere like Shenango County where
Yeah.
it's like foggy over half the mornings,
Okay.
does that mean you're going to get 16 snowstorms versus Onondaga County where there's only
Probably not.
4?
No.
I don't know how trustworthy
So
this
it's kind of widespread fog.
that's what they're saying.
Okay.
All right, and then the last quiz here, signs from climate. This is a tricky one. Thunder in late September or October is a predictor of A, it will snow in 10 days, B, warmer than average winter, C, little snow through New Year's Eve, or D, several thunderstorm events, thunder snow events. Thunder snow.
I'm gonna go with thunderstorm.
I'm gonna go D.
The Jim
it could-
Cantori answer, right?
You know, I was going to say B,
Could
but
be
I
like
like,
lake
the Jim,
effects,
I
I
like
don't
the Jim
know.
Cantori
I
answer.
am
Yeah.
going B, I think.
So we got some
I think
B's.
it's going to be B. I like D, but I'm going to say B.
All right, let's see.
And it's
Oh.
not
It'll
an
snow
L.
in 10 days.
It's
and
going to
that's-
snow in 10 days.
It's going to snow in 10 days. So if we see thunder, that's what they say. We'll see.
Are you saying it's going to snow in 14 days? Then?
Is that on the
Oh my
10-day
gosh.
graphic, Mike? After 10 days? No, the 10-day
It'll
outlook.
snow in 10 days.
Well, that's interesting because maybe it's because there was such a strong cold front that
Yeah.
brought a
There,
thunderstorm.
a
that maybe
strong and active weather pattern makes for a
okay.
sharp and early
Interesting.
change of seasons.
That means we're gonna see snow on Halloween.
I mean, it's happened before.
Oh Lord, get
Bold
ready.
prediction.
I really like. I thought
Yeah.
this is some really great stuff, Mike.
So
Yes.
yeah, a lot of people can relate to this. Farmers,
Right. Yeah.
those that look to nature. A lot of people are holistic. So I thought I would be, looking at both sides of the things, looking at all the science terms like you guys did, and give nature a turn.
And then
I
there's
like
something
it.
wrong with that because before there was actually science and math and all this other stuff, that's what they used. That's what they only could use is try to find some correlations with animals.
That's right.
Oh, you forgot one?
I got
No,
two more.
this is good. I love that. All right, can I be honest with you? You can go as long as you want, Mike.
Okay.
because I'm really enjoying
This is a
Do you have
big
any more
part
props?
too. No more props, no
Oh.
more games, no more quizzes. But we do have the forecasts from two of the prognosticators for winter using weather folklore.
Okay.
And the first one we're going to show you here is the Farmer's Almanac. The Farmer's Almanac
yes.
map is calling for cold, snow-filled winter here in the Northeast, including us. What's interesting about this graphic is they're saying cold in
Everywhere.
almost every spot, and then they're saying above normal precipitation, whether it's wet or snowy. So I think they just want to get everyone riled up.
Yeah.
They just want you to talk about it.
I'm a little confused about each of the color coding.
So this is cold and snow-filled in the blue, very cold and snowy, very cold. That doesn't
Yeah, isn't it the same?
really
It
make
looks
sense.
the same as the average.
What I find interesting, have you ever known that they're competing? There's the Farmer's Almanac, then there's the OG, the old Farmer's Almanac.
Oh,
This is better.
And they're not agreeing
I
with
was
the
just
other
going to say,
almanac.
that's what the one I thought you were showing. So
That was
that's
the Farmer's Almanac. This is the old Farmer's Almanac. Their forecast for this winter is cold and dry for central New York. So both are saying cold here in central New York. So we were cold
Yeah.
and snow-filled for that one. This one's saying cold and dry. The old Farmer's Almanac.
And it's interesting, even in New York State, it's split, with Eastern New York being milder. I noticed there.
I'm fine with the OG.
They even got cold and wet
the
in
less snowy.
Florida.
Well, based on your indicators, wouldn't that go completely against the Farmer's Almanac, though? Because the corn husk was thin. And was
Yeah.
it the squirrel nuts? What was that one?
I'm going to have to let them know about our
Yeah.
results because
Yeah. And the early leaf drop,
look at
everything pointing to a warm winter.
And cold and
Except
dry,
for the Farmer
we've
Almanac.
had bitter cold, so I guess the dry, I think they mean precipitation probably, but is it dry because it gets bitter cold and the dew points are like super low?
That can happen.
Right?
Yeah,
That could be a dry and cold together as well. So my interpretation of that map.
Listen, this is part of our calculation. Literally, the calculus that goes into some of our questions. Mike, great stuff.
Yes.
We
Thank
appreciate
you. Yeah, that
that.
was awesome.
Yeah.
Sam, what did you look at?
Yeah, so I don't have any of those major props. But I guess
Neither did any of us.
Yeah, I'll
I wanna
start
I'm going to
cleaning
bring my
this
A
up
game next year.
while I'm at it. But what I focused on was any type of simple statistical
Okay.
correlation between Lake Ontario water temperatures, surface temperatures, and then Syracuse snowfall
Okay.
through the winter months. So let
I
me
mean, lake
get in
effect
here.
snow was a big factor last winter.
Yes.
Yeah.
So,
Agreed.
Yeah, so that,
Yeah.
that was kind of my thought behind the whole thing was see if there is a correlation. In my head, my first hypothesis out of this was a warm lake would mean more lake effect,
Sure,
right?
you would think.
You would have like more of that temperature gradient between cold air over top of a warm lake. So
Sure.
that's initially what I had in my head.
All right,
But-
what'd you find out?
Yeah, we'll get there. We'll get there.
Oh, okay.
Okay,
I'm so interested.
so this first graphic is just a straight up yearly snowfall for Syracuse from 1950 all the way to now. So if you can take that full screen, the numbers are really small here. What I just wanted to show was the fluctuation here. So it is all over the place
sure is.
year to year. So you can see just 2012. So how this goes is 2011 to 2012, we only got 50 inches over here on the bottom right-hand side of the screen. And then back in, what would this be, 2011 to 2012, or 2010 to 2012, the years specifically don't matter, but up over 175. So year over year it changes 175 to 150, which is what makes this whole thing so difficult, you know? Overall, I took this data, our yearly snowfall totals, and then I also found these average Lake Ontario surface temperatures. And so they have an average surface temperature year over year for the month of September on Lake Ontario. It's pretty amazing what they can come up with their satellite data. And what this shows, it starts calculating it back in 1995. They started analyzing this data back in 1995, all the way to 2025. And the trend line is 1 degree warmer every decade is what they've found year over year, which is almost a confirmation of global warming, climate change in itself, which kind of through this entire study is more or less what I've found, kind of confirming.
Yeah, water temperatures, not just Lake Ontario, but everywhere.
Warming
Most
water
places.
temperatures, yeah.
Okay.
Okay, so I did all of the correlations between year over year from 1995 to 2025, and then matched that up with the September lake water temperatures from the year before,
Okay.
if that makes sense. So say September of 2024, and then I compared that to the snowfall totals from 2024 to 25.
Got it.
Okay. And so what I found was September Lake Ontario temperatures below 67 degrees. And so I kind of divided them up into below 67 degrees, between 67 degrees and 69 degrees, and above 69 degrees, just to kind of simplify, because I know it, I can just get into the weeds with this thing. So the below 67 degree Lake Ontario water temperatures, what I found was 60% of those years where September Lake Ontario temperatures below 67 degrees was above average snowfall in Syracuse. Pretty shocking numbers.
So the temperature was lower.
So, so what that says to me is that a cold Lake Ontario temperature is more correlated with a heavy snowfall year,
Wow.
which was totally backwards
It's very
from what I was thinking. And
Like more frequent, more often snow events probably throughout the winter? Instead of just
all
the
I did
fall?
was totals.
Yeah.
So I guess I'm
I would,
unsure on that.
That's my takeaway from it. Is like maybe it's longer,
Yeah.
more often. I don't know.
Again, like that's exactly what I was thinking too. You can literally, once I was doing all this data analysis, you can just go and go and go and go. There's more questions than real answers out of this. So 10% chance of a below average snowfall year if the Lake Ontario temperatures are below 67 degrees.
And that's where we were, right?
Which we'll get there,
Oh, okay.
but pretty wild. It was just kind of backwards to what
Sure.
I was thinking. And then between 67 and 69 degrees Fahrenheit, you end up with a 70% of those years were below average snowfall years.
Jeez.
Again, these correlations were surprising, to say the least. And then when you have the above 69 degrees of Lake Ontario temperatures in September, then it's again 60% chance of a below average year.
Wow.
And after kind of like thinking through a lot of these things, what came to my mind was the reason why Lake Ontario is cold is because the year is colder, and
Right.
so you get more snow when it's cold. Like it's
Yeah.
straight up.
Not a
Like,
mix,
like
not
I
rain.
was overcomplicating it by thinking, oh, a warm lake affects snow, but really it's just general snowstorms.
Right. It got colder faster in
it got-
September.
Yeah. So
Kind of makes sense when you think about it that way, but
yeah.
you would. That's interesting. I wouldn't have expected there to be such a drastic difference between
Yeah.
67 and then above 67.
Well, maybe.
Here, when you look at these years for the above 69 degrees Fahrenheit for Lake Ontario, it was 2024, 23, 22, 21, 18, 17, 16. So these are all very
I
recent
was going to
years.
say, those are
Okay.
These are all
easy
very
years,
recent
yeah.
years. So the lake has been very warm recently.
Because of it being so warm temperature-wise around.
Yeah, and so you think of these past 5 years, we've gotten very little snow. So this is a 30-year data group we're looking at. Maybe that could skew it a touch.
Right, because it's just a small sample.
Yeah, because it's a small sample itself. But then also you think of, well, we're getting more rain out of it because
Mix,
it's warmer.
Yeah. I was also thinking types of snow too, because when it's colder, you can get a lot fluffier snow rather than when it's warmer, you get more of a compact, dense, wet
Heavy,
snow, or even a mix of rain and snow, and maybe the total number of actual snowfall is lower.
Yeah. Well, and
Sleet freezing
then
rain, too.
just to kind of piggyback off of like how recently the lake has been warm, it was below 67 degrees 1995, 97, 2000, 2003, 2004. So those were also a longer time ago. So the lake was colder a lot longer ago, and now it's been gradually warming. We've been getting less snow recently. And so it's like, is this kind of some statistical correlation? There's a difference between the lake causing less snow or just a correlation between the two. This is a correlation. But with the global warming and climate change, are we getting more rain during the winters and less snow? And so is our average of 127 inches really our average anymore?
I question that a lot too.
Yeah, and just in case everybody knows it, it's a 30-year running average. So every 10 years they do update it. So it's, I think, 1991 to 2020. But like
Okay.
you just mentioned, all those years, the last 5 of those years, or I can't
Really
remember the
brought
exact
down.
number, but
Yeah.
most of them have been below average to skew
Yeah.
us and pull us down. So
Yeah.
maybe if this continues, maybe the next 10-year average will be lower because of the recent changes. Very interesting stuff. All this information is part of the reason why it's so difficult to forecast.
Sam, were you going to get into what it is this September?
Yeah, so
Because you just gave us those past years. Now, where does that plug in?
yeah, so this past September, we had a average Lake Ontario sea surface temperature of 67.63 degrees Fahrenheit. So it falls in that 67 to 69 range, which is this one.
Isn't that the big red below
That's
average?
the big red one. That's below
Oh, snow
average.
fans are not going to like that, Sam.
So based on statistical correlation here, going significantly below average on the snowfall, kind of like what we've seen in the past 5-6 years, even considering last year was below average
Slightly,
for us.
yeah.
Slightly.
Yeah.
So, yeah, that's what I'm going. 10% chance of above average and 20% chance of average. So I'm going dry. Skiers are going to hate me.
No.
Well, let's also not forget, this is just, a
part of
it. It's just part of it. Any kind of a forecast that goes out months in advance, no matter what folklore or stats or computer models are going to use, it's going to be, I don't want to say unpredictable, but one of the toughest forecasts that even people that just do this all the time,
Yeah.
they're not right.
I want to say one thing real quick. I apologize for the bell curve. I think I talked about in my segment there, where I had equal, below, and above. In the above average seasons, ready? 140, 150, 160 inches. Okay, so you
remember you
need to
telling me
keep
about
that in the back
this.
of your mind. We're leaning average to below, but in the small chance that there's an above, it could be one of those years where it could be lake effect, it could be general snow, it could be. Sometimes you get the combination when you
Sure.
get that one system, two systems, wrap around, lake enhanced snow, all that. Just know that our percentages are small on the above average, but those years we got hit hard. The ones that I looked at.
And
Just want everybody to know
and
that.
that's why we put the 20%
Sure.
pie chart for our above average,
Sure.
because many of our researchers showed different possibilities, even within maybe a biasing of below average. There are still, even with Sam's stuff,
Yeah.
there's still a little chance that there could be an above average year. We did a lot of research this year, and a lot of fascinating results. By the way, thank you all for putting so much time into putting all this research online and all the graphics you showed. A lot of stuff I learned today from every one of you. Thank you so much for this. I want to recap our forecast and also show a map that I want to make sure it's not just a Syracuse thing, okay? This is the map of a typical average snowfall for our entire viewing area and even outside our viewing area. Yeah, This is a tough area to forecast for because you can get as little as under 50 inches in the gray to as much as 250 to 300 inches or sometimes even more for the Tug Hill, which, by the way, last year they got walloped lake effect snow season. I'm wondering if that might happen again, just looking at all the information about how the flow is. But either way, wanted to recap our snowfall forecast, so here it is. So, this is our forecast for the entire winter season for snow and temperatures using all of the data we gave you. All right, we're going with a 40% chance of near average snowfall. The average for Syracuse is 127.8, so it would be, let's say, plus or minus 10 or 15 inches from that. A 40% chance, which is about equal, of going below that, and there it is, as we were talking about. We are leaving that possibility because of some of the research we showed you. There are some years that even with all the pushes and pulls, you still get an above average winter for snowfall. For temperatures, again, we've got this still split where there's about an equal chance for above or near average numbers. But again, some of our research did show below average overall. I have a feeling there will be times, and I think everybody would agree here, there will be some cold air, there's going to be some snow, just how much we'll see. But I think that a lot of the research that we've shown is there is a spread where it's not, oh, it's definitely this or it's definitely that. My gut feeling is it might be similar to what we had last year, but only time will tell. Again, I'd like to thank all of our meteorologists here. I'm meteorologist Peter Hall.
Meteorologist Josh Kozlowski.
Meteorologist Violet Skyber.
And meteorologist Mike Brookins.
And meteorologist Sam Postich.
We're so happy that you've joined us for the 2025-2026 CNY Central Winter Weather Outlook. Have a great day.